Hello, Mr. Eric. Today we talk about binary trees. So what's binary trees?
I'm good.
Yeah, you're very good at binary tree. What's binary tree?
It's a upside down tree with numbers.
Okay, so can you write a tree, please?
Any binary tree?
Yes.
Yes. I'll put in one.
Okay, let's okay. Great. So how many leaf nodes in this binary tree?
Two.
Two. Which
One and two.
How many root nodes in this binary tree?
One.
Only one, yeah. So for any binary tree, it only has one root, right?
Yeah.
Which node has the zero parent?
Root.
Okay. And for the leaves, how many kids do the leaves
Zero.
have? Zeros. Okay.
Always.
Okay. Okay. What's in order? In order. Let's talk about pre-order first. What's pre-order? Pre-order, and then there's in order, and then there's the post-order. These are three ways of travel.
I think it's...
And there's the depth first search, yeah? Which one is the depth first search? Which one is the depth first search?
I think it's
Root what? Root left to right.
Yeah.
So this is root left to right. So node left to right, okay? Node left to right, okay? And breadth first search is level by level, right? And in order is what?
Left.
Left,
No.
node to right. What's post order?
I think it right. No.
Left,
Left. Right.
no. Look, post, you just, this is in the middle. This is in the previous, the first. This is in the last, right?
Yeah.
That's what they call it, breadth first search. So which one is the depth first search?
That one.
Yeah, this one
Pre-order.
is pre-order. Okay. Okay, so that's good. So we are given a pre-order and in order, and we can determine a binary tree, right?
Yeah.
Yeah. So let's do an example. For what? 42103. Okay. 42103.
That
So
looks
can you?
like really unbalanced.
Unbalanced. Yes, well done. So what's balance? What's unbalanced? What's balance?
A balanced one is like a full binary tree.
Not really. The balance is like the difference, the maximum difference between any left and any right is smaller than or equal than 1, right?
Mm-hmm.
So look, this is definitely not, right? Because look, this is a lot, right? It's not balanced, yeah. Okay?
Mm-hmm.
So what's the pre-order of this? What's the pre-order? Pre-order of this? Can you give me an example?
Okay, so it is 42103.
We're done. 42103, okay? 42103. And what's the in order?
21034.
21034. Okay, so now, given this binary tree, you can calculate, we know that the pre-order and in order. How about we don't know this binary tree, but given these, what's the stretches to be a list from these two, right? Yeah? This is thinking backwards, right? We given this binary tree, we know the pre-order and in order. But now we are given this, how do we build this tree?
Okay, so pre-order is right, left, right. Right?
Pre-order is node, left to right. Okay, so what does it mean?
And then you put the root first, which is 4.
Yeah, okay, well done. That's good job. So 4 is the root, right? Pre-order, yeah? So we know the 4. And then this in order is what? In order is what? Is L and R, yeah? Right? So this is given, right? This is given, right?
Yeah.
So we need to find this in the n, in the second, which is here.
Yeah.
And then we know this, we find it here. So we know this bit
So
is
which means there's no right.
yeah, this is left, and then this is right, right?
Yeah.
Yeah, does it make sense?
Yeah.
So in this case,
There's no
we
right.
can, yeah, I know, we can, but in some cases they are right, right? But here, we find it, and then what should we, then we will need to build it, right? For example, let's build a tree with the right, okay? Okay, so let's see.
I can build one.
Okay, let's see this 9. Okay, so 4, 2, 1, 0, 3, 9, yeah? And what's the in order? 2, 1, 0, 3, 4, 9. Okay, yeah, I put the 9 here.
They're both last.
Yeah, okay, so look, the first thing is I need to build a root with the number 4, yeah? Right?
Yeah.
And then I find this 4 in here,
Yeah.
yeah? Then I know everything up to this is the left. Everything after is the right, right?
Yeah.
Yeah? Okay, so now,
Then you build the right tree.
now I put, I look, I use the 4, I take it out, yeah?
Yeah.
Okay, so now look, this 2, 1, so look, so let's pre-order 2103, it's on the left, so the left is, again, 2, right? Yeah? Yeah?
Yeah.
And then 2103, because we know 2103 is on the left, so this is 2103, and then that's 9. So look, 2 is on the left, 2103, and 9 will be on the right, right?
Yeah.
And 2103 again, I take it out, and then it will be 103, right? 103. So we can do this recursively, right? Because 2, and I find the 2 here, in the 2 here, so there is no left. All these are the right, right?
Yeah.
Does it make sense? Yeah.
Yeah.
Okay, so let's do this. Let's do this. Define build. Let's call it pre-order. And then it's in order. Not yet. What means? Yeah, wait up. Okay, so look, let's say if in order, okay? If not in order, okay? If we are using all the elements in the list, not in order, right? Or not pre-order is the same. No, we just return none, right? Okay, yeah.
Yeah.
Because it's empty list, we just return it, right? So now we need to find a root. Let's say the value is I, okay? I equals pre-order. Which element in the pre-order is the current root? Which element in the pre-order is the current root?
The first one.
The first one, yes. So how do we remove the first element from the list? Which is, I just said the word. Pop, yeah, pop 0, right?
Yeah, pop 0.
If we don't specify 0, what does it do? You will pop the,
Pop.
which one? Pop 0 is the first one. If we don't supply this 0, what does it do?
It pops.
Pops which element?
Uh,
Which is the other direction of first?
Last.
Yes, we're done. If we don't specify this 0, it will be the last one. So what's the complexity
And
of
it will
this?
be.
What's the time complexity of this pop 0?
ON.
And yeah. But if we are using double NDQ, it will be pop left, and which will be constant, right?
Yeah.
Yes. Okay, so now we have this root, and then the left. So let's say root, okay, equals new 3. Okay. Sorry about my alarm.
Ding ding.
So order equals 3, and then we given this I, right? This is the root, right? So now we need to build the left tree, and then build the right tree, yeah, right?
Yeah.
And then
Yeah,
we just need to
right.
return what? Return here. I build the root, I build the left tree, I build the right tree. I need to build what? Return what?
The tree.
Return root, okay? So the thing is, how do we build this? So we need to build, right? The pre-order, we already taken one element out, so the first element is pre-order, right?
And this is the same.
Yeah, because we already taken the first element out, right?
Yeah.
Yeah, so that would be recursive. It's always the first element, right? The root, right? The root. So now the thing is we need to find it in the in order, the in order thing. Okay, so look before, okay, let's say this 1, 2, 3, okay? 1, 2, 3. Just 3 elements, yeah? What's the in order? 1, 2, 3. Oh, what pre-order? 1, 2, 3, yeah? The in order is 2, 1, 3, right? Yeah? So we know this is root, yeah? So we need to find here, right?
Yeah, which is there in the
Okay.
middle. So this must
Yeah.
be the right and this is must be the left.
Okay,
No,
so
I mean this is the left and this is the right.
yeah, okay, so wait, there's a slightly problem, which is that we need to find it. Let's find it, okay? Let's find this pre-order pop 0, right? But we need to find it. Then let's do it in. How do we find it? Is you can do this in order dot index, right? Index. You will find this index, right? This is I will be index, but now the tree I will be. You can say is it will be pre-order dot pop because it already popped it, so I can say in order I, right? It's the same, okay? Right? Look, the reason I want to find this index, I slightly write it because I need to find this index, right? Look, Eric.
Yeah.
In order, pre-order dot pop 0, I take the first element out of this, which is 1, and I find it in the second one, which is this position. Yeah, and then in order I will be the root. It's the same, yeah. I equal 1. And then now everything up to this will be the left. Everything after will be right, right?
Yeah.
So this here, so that will be in order everything up to I, but not including the root, right? Yeah? And then here, what should I do here? In order, the right tree, what should I do? What should I do? Can you write it here? After I. So what?
Column?
I plus 1 column,
Yeah.
right? Because this I is the root, right? Yeah? Up to I, Eric, this format, from 2, not including 2, right?
Yeah.
So up to root, not including, that's fine. But here is from will be inclusive, so I will need to be I plus 1 here, right? Does it make sense?
Yeah.
Yeah. What's the term complexity?
Wait.
Oh what?
Square.
O(n) square. Why is O(n) square?
This is O(n).
Yeah, this is every time. Look, every time I will need to pop 1 from the beginning, and then I need to search it for the second one, right? I need to search it. This will take O(n), right?
What happens if this the root was 1 and there was 2 ones?
Okay, that's a good question, but we are assuming the pre-order and in-order is both correct to uniquely identify a binary tree. Okay,
Yeah.
so if you so there's no such case when they are duplicate numbers, right? Yeah, because look, we need to index. This is finding an element in the list. This is O(n) times. But how many times we need to potentially look for this n times? So the complexity is O(n) squared. Does it make sense? Because there are n roots, yeah?
Well, they have to be unique.
Yeah. Yeah. For example, if the tree is like that, yeah, always these.
Which is definitely unbalanced.
Unbalanced, yes. And then you need to look for these every time the root, yeah? Does it make sense?
Yeah.
Yes. So you will take O(n) time, and each one you need to search for n. So look, this pre-order dot pop, we can do this. So look, we can write this, yeah. Look, Eric. Look, we can say root of value equals pre-order, the first one, yeah. Pre-order 0, right? We got the root of value, and then I will be in order dot index root value, yeah. This is the same, but we need to get rid of the first one. So we can do this. We can do this pre-order, then we do this 1 dash, yeah. 1 dash. This is the same thing. So it means I will discard the first element. I will use the second element, right? This is exactly the same as the pop 0, right? Yeah. So this is much clearer, right? Root of value will be preorder.0, the first element, right? And I search this root value in the in order, right? Yeah? I don't want to recursively build it because I already know the first element is the root of the current node, right? Current tree. So I will, when I recursively build it, I will pop 0. I will discard the first one. Yeah, it's the same as pop 0. Does it make sense?
Yeah.
Okay, so let me quickly. No. Okay. Huh. In order, though what?
In order.
What's the keyword to look for the element?
Index.
Index, yes, index. Which index? Index what?
Pre-order.
Index which one? We want to index we want to find which element in the in order?
Root.
Root value, yeah. That's it. Okay, we are done today.
Bye.
Bye bye.
Bye.